Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase it immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 159. Please turn to page 159. Today is our lesson number 59. The problem that we are about to solve is number 55. Number 55. They tell us that we have three jars, P, Q and R. Let's set it up here on the side. So we have three jars, P, Q and R. And here's the red and green what, I do not know, marbles. We have red marbles and green marbles, and here are the quantities. Jar P has X red marbles and Y green marbles. This one is Y and Z, and this one is X and Z. What they are essentially giving us are three equations. There are three equations here with three unknowns, and if we wanted to, we can solve for all three of these variables. We could solve for X, Y and Z. They're not asking us to solve for X, Y and Z. They are looking for only one variable. Let's find out which variable they're looking for. They're asking us number of green marbles, in jar R. Well, here's our jar R, and here's the green marble. This is what they're looking for. They're looking for number of green marbles in jar R. Here's our jars P, Q and R, and the green marbles are right there. This is the variable they're looking for, Z. So that is Z is what we're looking for. And essentially, as I said, they're giving us three equations. Not essentially, that is what they're doing here. They're giving us three equations. They tell you that X and Y add up to 80. This is the total. So that's our first equation, X plus Y equals 80. Let's call it equation number 1. X plus Y equals 80. That's our equation number 1. Second equation, they go on to tell us that Y plus Z add up to 120. In the total part, they tell you this 120. So Y plus Z equals 120. That's our equation number 2. And then finally, equation number 3. And finally, the equation number 3 pertains to jar R, where we know that X plus Z has to add up to 160. That's all. As I said, three unknowns, three equations, three independent equations, three unknowns, and therefore we should have no problem solving for any of these three variables. Let's take a look at it, see what we can do. Equation 1 tells us that X plus Y equals 80. We are interested in Z, so here's what's going to go on. If we use equation 3 with equation 2, we're not going to get anywhere, because if we use equation 2 and equation 3 to work with, we're going to end up with X, Y and Z. We're going to end up with three variables. Our goal is actually somehow get rid of one variable, eliminate it, so that we can solve for the remaining variables. So that's not going to work. If we work with equation 1 and equation 3, again we'll end up with X's, we're going to end up with Y, and we're going to end up with Z. We will not be able to eliminate anything. So let's work with equation 1, which has X in it, and let's work with equation 3, which also has X in it, so we can get rid of the X's, and we'll have a new equation with Y and Z. And this is also Y and Z, so we can work with the new equation that we're going to create by combining equation 1 and equation 3. We're going to use that new equation, which will result as a combination of equation 1 and equation 3. Along with equation 2, we can solve for Z. Let's take a look. So here's the equation number 3. Equation number 3 is X plus Z. X plus Z equals 160. X plus Z equals better yet, just do the equation 2. Let's get rid of the Y. It really doesn't matter. It really doesn't matter. You see? if I was about to use equation 1 and equation 3, in which case we would have gotten rid of x's and we would have had a new equation in terms of y and z. Now I'm using equation 1 and equation 2, we'll get rid of the y's and we'll have a new equation with x and z. Either way, we'll have x and z, here we have x and z, it's the same thing. There's no one right or wrong way of doing things. Different people will approach it a different way. Even the same person will approach the exact same problem in maybe 2 or 3 different ways depending on their mood and depending on when you hand them the problem. You understand? One day they may do the same problem in one way, and then in the evening they do the exact same problem in a little bit different way. It's just whatever clicks. So equation 2 says y plus z equals 120. The reason I switch is because this is how I did it when I was doing it in my notes, so I want to stick with it. So this is plus, this is plus, this is plus. Let's subtract the second equation from the first equation. If we subtract the second equation from the first equation, the very first thing we should remember, we should get out of the way, is the fact that when you subtract an equation, all the variables are going to change their sign because we're subtracting it. So here we end up with x. Here we end up with x minus a z, and here since we're subtracting it, here we have a positive y, here we have a negative y. They're going to cancel out, and that will equal 80 minus 120, which is same as negative 40. So we have x minus a z equals negative 40. Now let's multiply both sides by negative 1. Let's multiply both sides of the equation by negative 1. And if we were to do that, we'll have negative 1 times x is negative x, and negative 1 times z is positive z. You see, since z is positive, I want to put it in the front. Another reason I want to put it in the because it's better to put positives in the front. I prefer it that way. Most people do. And here we have negative 40 times negative 1. Negative 40 times negative 1 is positive 40. And that's our new equation. Let's call it equation number 4. Equation number 4 that we created is the combination of 1 and 2, is the marriage of 1 and 2. Now we're going to use equation number 3. Obviously, because we used the 1 and 2, 3 is the one we have to use. Equation 3 says x plus z equals 160. We're almost there. Again, here we have a positive z, here we have a positive z, so 2z, and then we have a negative x here and a positive x here. A negative x and positive x is going to cancel out, and then we'll end up with 2z equals 40 plus 160, which is 200. If 2z equals 200, z must equal 100. Z equals 100, and that's answer choice. That's answer choice D. I don't think anything has gone wrong because it's a very straightforward, simple problem, but I'm going to check the answer in the back anyway, just as a confirmation. 55 D, that's right. So that's all there is. That's all there is. 3 equations, 3 unknown, very straightforward, very simple. I'm going to erase this part here so that we can keep it separate. There we go. See? That looks much better. I do all that thing so that I can erase it a second later. Do you understand? Anyway, this is it. I will see you tomorrow, okay? Bye now.